So we're going to do example 3, write and solve a system of equations to determine how many seats are in each of these sections of the amphitheater. And you can see they got a little map here. It looks like there's a section that's close to the stage, kind of further back, and then the lawn. Let's read through the information here. Seats closest to an amphitheater stage cost $30. Seats to the next section cost $25, and the lawn seats are $20. So there I have 3 different prices. Makes sense. Furthest away is the cheapest. There are twice as many seats in section A as in section B as in section A. When all 19,200 seats are sold, the amphitheater makes $456,000. Dang, that's a lot of money for a night. A system of equations and 3 variables can be used to determine the number of seats in each section. So when we're writing this here, we got to think about what our 3 variables are going to be. Now, we can just use x, y, and z. Here I notice they already gave me that the closest area is A, the next area out is B, and the lawn, well, if we're going by the alphabet, the next letter should be C. So there's my 3 variables. Now let's talk about the equations that we're going to set up. First, we are given information about the cost of each kind of seat, and if they sell all of the seats, how much money they're going to make. So if it costs me $30 for every single one of the A section seats, and $25 for every single one of the B section seats, and $20 for all the C section seats, and I sell all of those things, it's going to be $456,000. So there's my first equation, the total amount of money we're going to make. Now another equation, they don't tell us how many seats are in each section, but we are told that all the seats are 19,200. So where the last equation was the cost of each one of the seats, if I'm just counting the seats, A, B, and C, they should add up to be 19,200. That's great. These are 2 great equations here. And if we were just working with 2 variables, this would be enough. But there's a rule. If you have 3 variables, you got to have 3 equations. If you have 3 variables and you don't have 3 equations, you can't solve for all 3 of them. It's just not possible. It's one of the rules of math. You can't do it. If you got 3 variables, you have to have 3 equations. If you have 5 variables, you need 5 equations, right? The number of variables and the number of equations have to match up. So there's some other piece of information in here that I want to identify to write this third equation. So seats closest, cost, this, seats next section, 25, 20. Okay, so I used all that. There is this line in here, though. There are twice as many seats in section B as in section A. Well, what does that look like? Well, we got some relationship between seats in A and seats in B. One of them is twice as many. B is twice as many, which means we're going to multiply A times 2. And if that doesn't make sense, let's take 2 numbers. Well, let's take any number. How about 10? Let's say there's 10 seats in the B section. Well, if that's twice as many as A, you would have to multiply 2 times 5 to get 10. So there you can see why I multiply the A by 2, even though they described B as being twice as many, because you're counting the twice of the other section. So there's my last equation. 2A equals B. All right. Now, how do we go about solving this? Well, if 2A equals B, anywhere where I see a B in these original equations, I can substitute 2A, and that would get rid of one of my variables. So I'm going to change all these things out. So 30A plus 25 times B, but we know B is equal to 2A, plus 20C equals 456,000. And we have a single a plus b, which we know is equal to 2a, plus c equals 19,200. Now, I just am going to simplify these down here, and I'm going to move all this stuff over to the left, so I've got some space there. 38, 2 times 25 is 50. That's a total of 80 A's plus 20 C's equals 456,000. And A plus 2A is 3 A's plus C equals 19,200. Now here it's your choice if you want to do elimination or substitution. Since we already did substitution once, I'm going to do it again. I'm going to change this second equation that I just found here to solve for C. And 19,200. And I'm going to substitute it into the equation before that. So I have 80A plus 20 times C, which is the same as negative 3A plus 19,200, equals 456,000. And now let's do some distribution here. 80A, well, 20 times negative 3 is negative 60. A. 20 times 19,200, ooh, that's a big number. 19,200 times 20 is plus 384,000 equals 456,000. Scroll down and give myself a little bit more space to work with. And I keep solving the equation down. That's 20A plus 384,000 equals 456,000. Subtract that 384 from the 456, and I get 20A equals 72,000 divided by 20, and I get A equals 3,600. Let me double check to make sure that that's right. Minus 384,000. Yep, okay. So A is 3,600. So that tells me in this section A up here, there's 3,600 seats. That's a lot of people, but it's a big amphitheater. Now that I've found that A value, though, I can plug it back into one of these equations over here with the C, probably the second one because the coefficients are much smaller, and I can find out what my C value is. 3 times my A value of 3,600 plus C equals 19,200. 3 times 3,600 is 108,000 plus C, sorry, that's 10,800. Put my comma in the wrong spot when I was reading it. Equals 19,200. And we get C equals 8,400 seats. And now I've got the second value there. I'm going to kind of just box that so I can find it again real quick. And hey, look at that. I also have this relationship 2 times A equals B. So I know what my A is. 2 times A equals B. So 2 times 3,600 equals B. B equals 7,200. All right. So here we go. So our solution point is 3,600, or sorry, 3,600, comma, 7,200, 8,400. That is our solution point. A, comma, B, comma, C. Let's see what the question asked before. Make sure we're answering everything. Can be used to determine the number of seats in each section. So there you go. There's the number of seats in each section.